All right, so we are going to be building off what we learned from last week and the week prior to that on systems of equations by learning a new method for how to solve these systems called elimination. So what you guys learned last week and the week prior to that was the method called substitution, right? Which we talked about has to do with taking one number and placing it in to substitute in for another in order to solve this whole system, right? And after we solved this system using substitution, we always got an X answer and we always got a Y answer. So the types of problems that we're doing for this week are the very same type of problem in the sense that it's still solving a system of equations. What does that mean? It still means that we have two equations, just like we saw last week, right? It still means that we are trying to solve them in order to get two answers, an X and a Y. It's just a matter of using a different type of method. Now, depending on which method you end up liking, in the future, you can kind of pick and choose which of the two you actually want to use. And depending on the situation, one actually might be easier to use than the other. It kind of depends. But the reason I'm teaching you both different types of methods is because knowing both is very important for deciding later on which is going to be easiest for you to use in that certain problem. So what do we mean by elimination? So if you guys have ever recalled someone in a game or something, usually that's the term where we hear it, where someone will say, oh, you're eliminated, right? Which means another way of saying that is you're out, right? So if you're playing dodgeball, for example, and you get eliminated, it means you got hit with the ball and now you're out of the game, right? So elimination has to do with moving something out versus substitution has to do with moving something in. So it's kind of the opposite of one another in that sense. So when we're solving these systems, our goal is answering the question, which variable, right? And when we say variable, we're talking about our X's and our Y's here because that's the only variables we have going on. Can I move out? Okay. That's the goal. You want to eliminate something. You're not trying to prevent it. You want to have elimination. It's very similar to when in the past you guys solved problems like, for example, 2x equals 10, right? The goal was you wanted to get x by itself. So to do that, somehow I needed to be able to eliminate this 2. And the way I did that is by using opposites, right? So since right now this is 2 times x, I can use the opposite, which is division, right? And by doing this, I actually end up canceling this out, eliminating it, moving it out, and getting just x equals 5, okay? So we're using a very similar concept of eliminating in order to solve our system. So let's go back over here. The first question that we're going to go back to our first question by answering, how can I decide what variable I'm able to move out? So I'm going to look here. Here is where my x's are, and here is where my y's are. Notice that they are perfectly lined up between the two equations, right? X is stacked on top of x, y is stacked on top of y. That's good because it allows us to compare the two. So when I'm looking at this, I'm looking for, of these two lines, right? So here's one situation here, and here's the second in these boxes. Which one includes a relationship that automatically cancels the other out? Is it 5 and 1, right? So this is a positive, so don't forget the symbols in front. Those are important. This is a positive 1, and this is a positive. When there's no number, remember, you can insert a 1 there. It's an invisible 1, right? Does 5 plus 1 cancel out anything? No, right? It would give us a bigger number. It would just give us 6y. So that is not an example of eliminating anything. We didn't move anything out. We just created a bigger problem. However, if I move to this one here, I have -4 and +4. If I combine those two things, these are the direct opposite of one another, right? A -4x and a +4x are the complete opposite. So these actually do eliminate each other, right? Because they're the same exact number value, but one is negative and one is positive. this is our first step and this is what we want. To eliminate one of the variables. Great. So now we're going to do the same thing, but now we're not eliminating. We're just actually adding the two equations top and bottom. So I'm going to create almost like an addition problem here, like you would normally see, right, when you have like 5 plus 4 back in the day, right? Same thing, except there's just more information here. And we're going to add top and bottom like this. So we did this one, right? This would essentially give us 0, right? Nothing here because we eliminated it. But I don't have to write that because it's just going to get confusing. Just nothing. But then here I have 5 plus 1, so I get 6y. Great. Now here I'm going to bring down my equal sign, and now I'm going to do 2 plus negative 14 on my calculator, okay? So I'm going to show you what that looks like. I'm going to do 2 plus, and then negative 14 gives me negative 12. Okay. This is very important that when you're dealing with a negative like this that you use a calculator. Another way I could have done this, and sometimes we'll get a little bit confused about this, is you can also do 2 minus 14. It'll also give you negative 12, right? But it's important to understand that even if you do that step, right, skipping the plus negative 14, that you understand that you are still adding the top thing to the bottom thing. If you don't understand that, it might get a little bit confusing when you try to combine them, okay? So now that we're at this stage, this becomes very similar to what happens over here, right? Now we're trying to get this y by itself because we want an answer for y. We want to say y is some type of number. So the opposite here of multiplying 6 times y is to divide. So if I divide on both sides, this will allow me to get that y by itself. So now on my calculator, I can do negative 12 divided by 6, and I get negative 2. So that means my y is equal to negative 2. Great. But remember, with any system of equation, you want 2 answers, not 1. So I'm going to take this answer here of negative 2, and I'm going to go back to one of my 2 equations and plug it back in. Either one is completely fine. You cannot make a mistake in choosing which equation to plug back into. Just whatever you feel better about. I'm just going to do the second equation. So I'm going to rewrite 4x plus 1, right, that 1 here, oops, times parentheses, insert your parentheses. Instead of writing y here, now I'm going to insert this negative 2, and then I'm going to equal it to negative 14, okay? And now I'm going to solve. So I'm going to multiply this first, right? Because with PEMDAS, if I'm doing it from left to right, multiplication is going to happen before addition. Okay? So 1, use my calculator again whenever dealing with negatives so I don't make the mistake. 1 times negative 2 is negative 2. So this becomes 4x minus 2 equals negative 14. All right. Now I'm trying to do cancel out everything here, all of this mess, so I can get this x all by itself. So this is where inverse PEMDAS happens, right? We're trying to go in the opposite direction. Why? Because now we're not just trying to combine things and multiply things. We're actually trying to move things out, right? Eliminate things. When you're eliminating something, this is where inverse PEMDAS has to happen, not the normal left to right PEMDAS that we use. So if we're doing reverse, right, we have some subtraction and we have some multiplication. So subtraction, multiplication. In this order, subtraction has to happen first and then multiplication has to happen. So we're going to add 2 first, right? We're going to deal with the subtraction first. The opposite of subtracting is adding. So we're adding 2 on both sides. Now I'm going to take my calculator so I don't mess up those negatives there. And I'm going to do negative 14, and I'm going to add 2 to it, and I get negative 12. So now I have 4x equals negative 12, and the last step is to divide by 4 on both sides to get x by itself. And when I do that, I get negative 3. So x is equal to negative 3. And now I'm done because I've gotten my 2 answers. I have y is equal to negative 2, and x is equal to negative 3. Once you get those 2 final answers, then you can feel confident that you're finished with that problem. All right, let's try another one just to make sure that we get enough examples in so we are clear on how to do these problems. All right, our next example is negative 3x plus 3y equals negative 3, and 3x minus y equals 7. As much as possible, you want to try to line everything up so that you can see it in like kind of these rows, top and bottom, right? So that I could essentially like do one of these to separate everything. Okay, so now that I've done that, I'm going to put a little plus here and a little line because I'm going to end up adding my columns. But before that, the question again I need to answer is, which of my variables am I able to move out or eliminate from this issue? So if I start here, I notice that I have 3. And whenever there's no number here, you can always write in your 1 so that you're not confused. Okay? Is it true that 3 minus 1 actually cancels each other out? No, we know that that's true because if I did 3 minus 1, I would get 2, which is not 0, right? So I haven't really successfully done this step. So it's not going to happen here. What about on the x's? If I do negative 3 and positive 3, these are opposites of each other, right? These completely will cancel each other out. So this is where I want to start. Cancel those out. Great. Next step is I can just add everything top and bottom. This is already nothing, so don't have to worry about this column here. This, though, I can now add. So I do 3. You can either do, remember, you can either do 3 minus 1. That works, right? You get 2, 2y. Or you can do 3 plus negative 1. And you still get 2, okay? Then I'm going to do the next thing. So negative 3. So negative 3 plus 7. Negative 3 plus 7. And I get 4. So this side becomes 4. All right, next step is I have to get this y by itself. So the opposite of multiplying here, 2 and y, is to divide by that 2. So we can cancel here, cancel here. So y equals 4 divided by 2 just gets me back to 2. Great, I have half of my answer now complete. The last thing is I have to take my answer and now plug it in to one of my 2 equations to get my my x. Again, it does not matter which equation you choose. So in the first example, I chose the second equation. So now I'm just going to choose the first. It doesn't really matter. So I'll do negative 3x plus 3, and then parentheses y, right? Y now is 2, so I can do times 2. Move this over just a little bit. Equals negative 3. All right, now because this is PEMDAS forward, right, in the normal order that we go, we're going to actually multiply before we add. Okay, so we're going to do 3 times 2, and we get 6. So we get negative 3x plus 6 equals negative 3. Now, because we're actually trying to get x by itself, we're trying to move some stuff out, we have to do reverse PEMDAS. Okay, so if we're going in this direction, we actually see that we have addition here, and we have this multiplication between negative 3 and x. In this direction, addition has to happen first. So we're going to address this plus 6 by subtracting on both sides. Okay, so we get negative 3x equals, and then again, dealing with negatives here, so I'm going to do negative 3 minus 6, and I get negative 9. Okay, and then the last step is to divide by negative 3 on both sides to get x by itself. So I'm going to do negative 9 negative 9 divided by negative 3, and I get positive 3. So that means x is equal to positive 3. And I'm completely done with this problem because I have 2 answers to this system of equations. Great. Let's do one more example together to really solidify this in our minds, and then we'll be done, and you're on your way to doing some of these problems on your own. All right, next problem is negative x plus 4y equals 14. And we have x minus 6y equals negative 18. All right, so again, just for clarity's sake, I'm going to actually segment these different chunks like this so we can see everything together. Draw that plus sign underneath. All right, so my first question is which variable can I move out? So if I start here, I have a 4 and a negative 6. So let's just check just to make sure. What happens if I do 4 plus negative 6? It gives me negative 2. I can write that down, negative 2y, that's fine, but it doesn't actually cancel each other out. However, these two do. Remember, when we have no number in front, you can always add in that number. So this is a negative in front, and then I can put a 1 there, and then this one I can put just a regular 1, right? So positive 1 and negative 1 cancel each other out. So this is gone. Great. So well, now we're going to add top and bottom. We've already canceled this out. We've already added these together. Now we can add the other side. So we have 14 plus negative 18, which gives me negative 4. So 14 plus negative 18 is negative 4. All right, now we're going to cancel out our numbers to get y by itself. So we're going to divide by negative 2 on both sides. So now we have negative 4 divided by negative 2, and we get positive 2. So y is equal to positive 2. Great. Now let's plug it back in. So pick any one of your first or second equations to use. I'll use the first one this time. So I have negative 1x plus 4 parentheses 2. So I'm plugging in for y here, that answer that we got, equals 14. Okay. Now based on regular PEMDAS, moving from left to right, we have some multiplication and we have some addition. And we're going to address the multiplication first. So I'm going to do 4 times 2, and I get 8. So I have negative 1x plus 8 equals 14. All right, now we're doing reverse PEMDAS, opposite direction. So if I'm going in this direction, I have some addition here and I have some multiplication. And I'm going to address the addition first since I'm moving from this way to this way. A comes before D in that order. So to get rid of this plus 8, the opposite would be to subtract it. So I subtract it on both sides. So you get negative 1x equals, and then we'll do 14 minus 8, and we get 6. Okay. Last step is to divide by negative 1 on both sides. Okay, so we do 6 divided by negative 1, and we get negative 6. So x is equal to negative 6. And that's our final answer. So we have our y answer and we have our x answer. So that's how we know that we are fully complete and done with this problem. And that's it.